Okay, so today we will discuss the previous year questions from the chapter Matrices. Okay, so let's move. Our first question is question number 1. If A is a matrix, A is a 3 cross 4 matrix, and B is a matrix such that AB and AB transpose both defined, then find the order of B. Okay, so before solving this question, let's revise the concept of multiplication of a matrix. So if a matrix A is of order m cross n, what does it mean? It has m rows and n columns. M rows and n columns. And B be a matrix of n cross p, then AB is m cross p matrix. So we can multiply two matrices if the first matrice's column number is equals to, this is the column number, equals to the second matrice's row number. Okay, so AB is defined, but in that case BA is not defined, as here the first matrix is B. So what is the column number of B? That is P. And what is the row number of the second matrix A? That is M, and M is not equals to P. So BA is here not defined. Okay, so if matrix multiplication is not commutative, AB is not BA for all AB. Okay, so how to multiply two matrices? If the column number of the matrix at left hand side is equals to the number of rows of a matrix in the right hand side, the matrix multiplication will be defined. Now here A is a 3 cross 4 matrix. So as B is defined, so AB is defined. As AB is defined, hence B must be something like this, 4 into P form, because as AB is defined, so the number of columns of A should be equals to the number of rows of B. Okay, so if AB is defined, then B is something like 4 cross P order. Now we know what is the transpose of a matrix. If we interchange the rows and columns of matrix, we will get the transpose of its matrix. Okay, so here B is something 4 cross P from, so B transpose will be, if I am interchanging the rows and columns, I will get a P cross 4 matrix. Okay, now it is also given that AB transpose is also defined. AB transpose is also defined. What does it mean? It means the number of columns of A will be equal to the number of rows of B transpose. It means P is also equals to 4. Okay, so B transpose is a square matrix of 4 order. Hence, for a square matrix, the order of a matrix and its transpose is always equal. So the order of the B will be 4 cross 4 2. Okay, that's a quite good question. Let's move to second one. Okay. Next question. Question number 2. If x into x is a scalar 1 2 plus y 2 5 is equals to 4 9, then determine what is the value of x and y. What is the value of x and what is the value of y? Okay, now we can add only those matrices whose order are same. Okay, now here you can see this matrix is of order 2 cross 1 and this is also order of 2 cross 1. So after adding them we will get another 2 cross 1 matrix. So we can add them, and if I multiply some scalar with some scalar means some number with a matrix, then it will be multiplied to each element of the matrix. Okay, these are some basic properties of matrix. So if I multiply x, I will get x to x. Similarly for this case also 2y 5y is equals to, now if while adding two matrices we will add the corresponding same order element. Okay, so these two are the first element of this matrix, so we will add the corresponding elements. We will get x plus 2y 2x plus 5y, that is equals to 4 9, right? It is given. Now two matrices are equal when their corresponding elements are equal, right? Say A equals to a matrix Aij of m cross n and B matrix of Bij m cross n are equal if Aij equals to Bij. It means the corresponding elements are equal. What does it mean? It means that x plus 2y equals to 4, 2x plus 5y is equals to 9. Okay, this is the equation number 1. This is the equation number 2. Now multiply 2 with equation number 1. We will solve it using elimination method and subtract it. So 2 subtract 1 into 2. We will get 2x plus 5y, and subtracting this we will get 2y minus 4y, 9 minus 8. Let's cancel it. So y equals to 1. Now let's put this value in 1. We will get x plus 2 4. So x is equals to 2. Okay, so solved. Now next question. Okay, let's move to the next one. Question number 3. So what is the question number 3? Question is given as A be a row matrix. What is row matrix? A matrix which consists only one row. Okay, that's called a row matrix. So row matrix 1, 2 and 3. This is my row matrix. Now it asks to find the product of A and A transpose. Okay. So what is the order of this row matrix? That is one row and there are three columns. So A cross 1 cross 3. So what will be the order of A transpose 3? That will be a column matrix which has 3 rows and 1 column. Let's interchange the rows with columns. So this is the transpose. It is a row matrix and its transpose will be a column matrix. So let's multiply now. 1, 2, 3. 1, 2, 3. So just simple multiplication. That is 1 cross 3. That is 3 cross 1. So what will be the order of their product is 1 cross 1. It means only just a number, scalar. So 1 into 1 is 1, plus 2 into 2 is 4, plus 3 into 3 is 9. So that is 14. Okay. Now question number 4. We have to find the product of this matrix A, B, minus B, A minus B, B, A. So let's product it. A into A is A squared, B into B is B squared, A into minus B is minus AB, B into A is plus AB. We will multiply like this, taking the first row, then multiply with the first column, then we will get this first element, then again with this row we will multiply this column, we will get our second element, right? That's minus AB plus AB, minus B into minus B is B squared plus A squared. So my answer will be A squared plus B squared, 0, 0, A squared plus B squared. Okay. That's my answer. Let's move to another question. Question number 5. Sorry. Question number 5 states that if A equals to A equals to 1021, B equals to x 0. Okay. It is given that A equals to B square. It is given. Now let's find x. So what is the solution? Okay. So here A is equals to B square. So let's write 1021. That is B square. So we have to compute B square here. 1 equals to, let's multiply it, x square 0. So that is x square 0, 0. So that is 0. X plus 1. So x plus 1, 0 plus 1. So if we these two matrices are equal, so we have to compare the corresponding elements. Okay. So here we can see that this 1 is equals to x square. So x square is equals to 1 and this x plus 1 is equals to 2. Okay. So from here x can be plus minus 1 and from this we got that x equals to 1. So x is not equals to minus 1. What is the final answer? X is equals to 1. Okay. If you are getting x square equals to 1, so many of you will finish the problem here, but it's not correct. Here is also another relation, that x plus 1 equals to 2. So from this we will get the correct answer. Okay. So let's move to the next question. Question number 6. So what is the question number 6? It is given that A equals to Aij is a square matrix. Is a square matrix of order 2. Of order 2 such that Aij is equals to 1 whenever I not equals to j, and 0 whenever I equals to j. Okay, so let's construct the matrix. It means that while the diagonal elements where I is equals to j, the diagonal elements are 0 and non-diagonal elements are 1. Okay, so my matrix will be, as it is a 2 cross 2 matrix. So 1 element is 0, 1 element is 1, 2 element is 1, and 2 element is 0. Now I have to find the a square. So how we get a square? By multiplying this with it. So by multiplying this, I will get 0, 1, 0, 0, 0, 0, 1. So that is my 2 cross 2 order identity matrix. Okay. This is an important question for your board exam this year. Okay. Let's move to the next page. Okay. Here's an interesting question from year 2022. That question number 7. It is asking that the number of all possible matrices, the number of all possible matrices of order 2 cross 3 with each entry with each entry 1 and 2. Okay. So the number of all possible matrices of order 2 cross 3 which with each entry 1 and 2. So let's consider a 2 cross 3 matrix, say this, where 2 rows and 3 columns, A11, 1, 2, A13, A21, A22. We will use some permutation and combination logic here. Okay. So here total are 6 elements. Okay. And for the first element, what are the choices? We have two choices. One, either 1 or 2. So for the first element, here only 2 choices. Similarly for the second element also two choices, third element also two, similarly for fourth, fifth and sixth also. Because for each place we have only two choices, either one or two. So we will multiply those and we will get 2 to the power 6, that is nothing but 64. So we have total 64 matrices of 2 cross 3 order with each entry 1 and 2. That's very important question and interesting one also, because it is using permutation and combination chapters logic also. Okay. Question number 8, another important question. It is given that a matrix is symmetric and also skew symmetric. And also skew symmetric. What is the trace of the matrix? Now we will discuss three concepts. Solution. Let A be the matrix. A be the matrix. And what is given that? It is given that it is symmetric. So what does it mean? Asymmetric. Asymmetric. Symmetric means this matrix is equals to is transpose. If we take transpose, the matrix will be equal to its original form. Okay. So it is our first given condition that A is symmetric. Let's move to the second condition. It is given that A is skew symmetric also. So it is given that A is skew symmetric also. What does it mean? Skew symmetric means A is equals to minus of A transpose. Okay. From symmetric we got that A is equals to A transpose. From skew symmetric we got that A is equals to minus of A transpose. It can be also written as minus of A equals to A transpose. So A transpose is equals to A and also of minus A. So A is equals to minus A. A is equals to minus A. From this I will get 2A equals to 0. It means A equals to 0. What does it mean? It is not 0, it is null matrix. It means that all of the elements of A is 0. Okay. Our question is not finished yet. It is asking that what is the trace of the matrix. Now what is trace? Trace of A matrix is nothing but the sum of its diagonal element. Sum of its diagonal element. Sum of its diagonal element. So as it is a null matrix, what will be the trace of this matrix? That is 0. Because all elements are 0, hence the diagonal elements are also 0. So what will be the trace of this matrix? The trace is also 0. Let's move to next question. Okay. Question number 9. It is given that if
3c plus 6 a minus d a plus d 2 minus 3b is equals to 12 2 minus 8 and minus 4. Then we have to find what is AB minus CD. So simply we have to determine A, B, C, D first, then we will get this value.
Okay, as if two matrices are equal, their corresponding elements are also equal. So this 2 minus 3b is equals to minus 4. Okay, so this 2 minus 3b is equals to minus 4. From this we will get 6 equals to 3b. So b is equals to 2. Okay, now it is given that a minus d is equals to 2, a plus d equals to minus 8. So by elimination method we will see that a will be cancelled out. Sorry, that will be a minus. So minus 2d is equals to 10. So d will be minus 5. So what will be the a? A value will be plus 5 equals to 2. So a will be minus 3. And from 3c plus 6 equals to 12, we will get c equals to 3c equals to 6. It means c equals to 2. Okay, so we got b equals to 2, a equals to minus 3, d equals to minus 5, and c equals to 2. So let's calculate the value of this identity. A is minus 3 into 2 minus, what is c is 2 into d is minus 5. So that is minus 6 plus 10. So that's my answer is 4. Okay, let's move to the next question. Actually, this chapter is the easiest chapter in your 12. We have to score the full marks from this. Okay, in this question, two matrices are given. Suppose P be given like 3, 4, minus 1, 2, 0, 1. That is my P. Now Q transpose is equals to minus 1, 2, 1, 1, 2, 3. Okay, now we have to find the value of P minus Q. So P is given minus 1, 2, 0, 1, minus, from Q transpose we can easily got the Q, that is minus 1, 2, 1, 1, 2, 3. Now we will subtract the corresponding elements. 3 minus minus 1 will be 4. 4 minus 1 will be 3. Minus 1 minus 2 will be minus 3. 2 minus 2 will be 0. 2 minus 1 will be minus 1. 1 minus 3 will be minus 2. Okay. Okay, question number 24 says that. Okay.
2i plus 3j whenever j is less than 1, 5 whenever I equals to j, it means diagonal elements are 5, and 3i minus 2j whenever j is, sorry, that is, first condition is I is less than j, sorry, I is less than j, here I is greater than j. Okay. Okay.
So aij, that is a11. So that's the diagonal element. What will be it? This is 5. The second element is a12. In this case, j is greater than 1. I. Here for the second element, I is equals to 1 and j is equals to 2. So I is less than j. So we will use this value. Let's compute what will be it. 2 into 1 and 3 into 2 is 8. So that is 8. Similarly, for the next, I is 1 and j is 3. So my value will be 2 into 1 plus 3 into 3, that is 11. Next, this element is also 5, this element is also 5. Here, I is 2 and j is 1. So I will is greater than j. So what will be my element? 3 into 2 minus 2 into 1. 6 minus 2 is 4. Now this is 2 comma 2 3 element, second row and third column. So here also I is less than j. You will be use again this formula, 2 into 2 and 3 into 3, that is 4 into 9 is 13. Here 3 1 element, so we have to use this 3 into 3 minus 2 into 1, 9 minus 2 is 7. So for the second element 3 2, here this element is 3 2 element, so 3 into 3 minus 2 into 2, so 9 minus 4 is 5. So that is my matrix. What are they asking in the question? The number of elements in A which are more than 5. So more than 5, here 1 element, 2 element, 3 element and 4 element. So there are so there are 4 elements. There are 4 elements greater than 5. Okay. Okay. Question number 12. A is a square matrix. It is given that is a A is a square matrix such that A square equals to A. It is given. Now we have to compute the value of I minus A whole cube plus A. We have to find the value of this, okay? So solution. So I minus A whole cube plus A is equals to, we will factorize it or simplify it from the A minus B whole cube formula. What is that? I cube minus 3A squared, sorry, 3A plus
3a square minus a cube plus a. Okay. Now, if we multiply identity matrix with identity matrix again and again and again, we will get the identity matrix. So that will be I. Okay. So minus 3a, and it is given that a square is equals to a. So that's also a. These two will be cancelled out. Now this a cube can be written as a square into a plus a. So a square is equals to a. So it can be also written as a into a plus a. So that is also minus a square, and this a can be written as also by a square. So this will be also cancelled out, and I, this is the my required answer. Okay. This is also important. Okay. Question number 13. Now I am writing a note of this question. This kind of proof sometimes asked into the question. If A is an odd ordered skew symmetric odd order skew symmetric matrix, skew symmetric matrix, A is an odd order skew symmetric matrix, then its determinant will be 0. We will discuss determinant tomorrow, but write this note. Okay, that's an important note. Okay. Okay. So let's move to the next question. Our next question is that if A equals to if A equals to minus 3 to 1 minus 1 and B equals to, oh, B is not given, identity matrix is given 1 0 0 1. So if a square plus I, a square plus I equals to ka, then what is the value of k? Okay. K. Okay. K into 3 into 9 plus 2 9 plus 2 is 11, minus 6, minus 6, minus 2, minus 3, minus 1, that is minus 4. 2 plus 1 is 3. 1 0 0 1, that is equals to minus 3k, 2k, k minus k equals to, while adding this we will get 12 minus 8 minus 4 plus 4 is equals to minus 3k, 2k, k minus k. Okay, so by comparing the corresponding elements we will get that k is equals to 4. Okay, that's an important question.
Now from matrix you will get this kind of short questions, but there is a special kind of long answer type question which is asked from this chapter. What is that? You will be given a matrix. You will be given a matrix, say P. Then they usually ask a 3 cross 3 matrix. They will give a 3 cross 3 matrix. Then they will ask you to represent it as a sum of a skew symmetric matrix and a symmetric matrix. So you will be given a matrix, then you have to represent it as a sum of a symmetric and skew symmetric matrix. This is also a note. Write a note here. So what is the note? It is written that every square matrix can be represented can be represented every square matrix can be represented as a sum of symmetric and skew symmetric matrix. A sum of a symmetric skew symmetric matrix. So we will prove it, then we will move to our problem. Okay, so proof. You have to practice this proof also. This is an important proof. Suppose say P be a given square matrix. Now I can write this P as half of P plus P transpose plus half of P minus P transpose. Okay, you can clearly see from this we will get that half P and half P will be added and become P, and this half of P transpose and minus of P transpose will be cancelled out. Okay, now we have to prove that one of it is symmetric and one another is skew symmetric. Okay, then our job is done. Say C equals to half P plus P transpose. Let's take the C transpose. Transpose. Transpose has no effect on the scalars, so half will be taken out. P plus P transpose transpose, then that is equals to half of P transpose, and what will be the P transpose is transpose, that is again the P matrix. So we can see this is equals to C. So C is equals to C transpose, hence C is symmetric matrix.
Okay, D equals to half P minus P transpose, P transpose. What is the formula of sum in transpose? Formula is A plus B transpose is equals to A transpose plus B transpose. And what is the transpose of a transpose? That is again the A. Okay. Now from this we will get A transpose, and also if Ka transpose is equals to K A transpose. Okay. We are using these three formulas here. P transpose is equals to half P transpose minus P, that is equals to minus of D. It's clearly this is minus of D. Hence D is skew symmetric. And now if you take C plus D, clearly half of P minus P transpose is equals to P. So it is proved that any squared matrix can be represented as a sum of a symmetric and a skew symmetric matrix. So what will be the symmetric matrix? The symmetric matrix is half into P plus P transpose. And what is the skew symmetric matrix? That half into P minus P transpose. Okay, let's move to a problem. Let's proof is very important. So let's mention it. It's very important. Let's move to problem. Question number 16. Let me think about a 3 cross 3 matrix at first. Let's take this matrix. A equals to A is given as 3 minus 2 minus 4, 3 minus 2 minus 5, 1 minus 1, 1 and 2. This is our given matrix. We have to represent it as a sum of a symmetric and a skew symmetric matrix. So write A can be written as A plus A transpose plus half of A minus A transpose. We have to name them as P plus Q. I am writing in the same way. In that way, you will have to write in exam also. Okay. So this is my A. Now what is P? Let's compute P. P is half of A plus A transpose. So let's compute it. Half. What is my A? A is given 3 minus 2 minus 4, 3 minus 2 minus 5 minus 1, 1, 2. And what is A transpose? A transpose is 3. We have to interchange rows and columns. Minus 2 minus 4, 3 minus 2 minus 5 minus 1, 1 and 2. Okay. So after taking the sum, we will get 3 plus 3 is 6, 1, minus 4 minus 1, that is minus 5, that is also minus 2 is 1, minus 2 and minus 2 will be minus 4, That's also minus 4, minus 5, minus 4, and 4. Okay, so what is our P? Our P will be 3 half minus 5 by 2 half minus 2 minus 2 minus 5 by 2 minus 2 and 2. This is my P. Now let's take the P transpose. After taking P transpose, we will get 3 half minus 5 by 2 half minus 2 minus 2 minus 5 by 2 minus 2 and 2. That is simply is equals to P. Hence, P is symmetric. P is symmetric matrix. Now let's compute Q. What is Q? Q is equals to half of A minus A transpose. Okay, so that is half. What is A? A is 3 minus 2 minus 4, 3 minus 2 minus 5 minus 1, 1, 2. Okay, minus. Now A transpose, what is A transpose? 3 minus 2 minus 4 minus 2 minus P. Okay, so let's compute the subtraction. Our subtraction will be 0 minus 5 minus 3 5 0 minus 6 3 6 0, and after dividing by half we will get 0 minus 5 by 2 minus 3 by 2 5 by 2 0 minus 3 3 by 2 3 and 0. Okay, now what is Q transpose? Q transpose is nothing but 0 minus 5 by 2 minus 3 by 2 5 by 2 0 minus 3 3 by 2 3 and 0. That's clearly minus Q. So what we can conclude? We can conclude that Q is skew symmetric, is Q symmetric, skew symmetric. Now P and Q, P is symmetric and Q is skew symmetric. We have to verify also. Let's P plus Q. This process is very much important. This verification process. Without this, your question will be not considered as a correct answer. Okay, so you have to verify it. So P plus Q is equals to 3. What is P? What is P? Half. P is 3 half minus 5 by 2 half minus 2 minus 2 minus 5 by 2 minus 2 2 plus Q. So what is Q? Q is simply 0 minus 5 by 2 minus 3 by 2 5 by 2 0 minus 3 3 by 2 3 and 0. If we add them, we will get 3. First element here, half and minus 5 will be minus 4 by 2, that is minus 2. Minus 5 and minus 3 by 2 is minus 8 by 2, that is minus 4. Half and 5 by 2 is 6 by 2, that is 3. Minus 2 plus 2 is minus 2. Minus 2 minus 3 is minus 5. Minus 5 by 2 plus 3 by 2 is minus, it's minus 2 by 2, that is minus 1. Minus 2 plus 3 is 1. 2 plus 0 is 2. So that's equals to my matrix A. So it is proved that a matrix A, this is our given matrix, this is represented as a expressed as a sum of a symmetric and a skew symmetric matrix P and Q. In each year, this kind of question will be asked in your paper for marks 5, and with it there will be a question from determinant, that system of linear equation will be in OR. We will discuss it tomorrow. Okay, I hope it is clear. Okay, so that's much today. We will discuss determinants tomorrow. Okay.